Hail can devastate crops, damage buildings and cars, and cause serious injuries to people and animals. But exactly what is hail, and how does it form? Hail consists of lumps or balls of ice which are produced inside thunderstorms. To form hailstones, we need the same kind of conditions we had in last episode, where ice crystals and snow pellets are colliding to produce lightning inside a storm cloud. One important detail needs to be added here though. Nearly the entire cloud where this is taking place is made up of supercooled water droplets. These water droplets are at well below freezing temperatures, but they remain in liquid form because in order to freeze, they need some bit of physical matter to freeze onto. Ice crystals lofting on the storm's updrafts grow and form into snowflakes higher up in the cloud by collecting these supercooled water droplets on their surfaces, and the snowflakes in turn gather droplets as they fall back down through the cloud, which turn them into snow pellets. In a normal thunderstorm, that tends to be the extent of it. The cloud produces lightning from the ice crystals and snow pellets bumping together, and the snow pellets melt into raindrops before they reach the ground. In a particularly intense thunderstorm, though, where stronger updrafts are able to catch the falling snow pellets and keep them aloft inside the cloud, it starts the process of producing hail. If the updrafts are just strong enough to keep the snow pellets from falling any farther, the pellets will bob and spin in place, gathering more and more supercooled droplets, which freeze solid, growing the hailstone almost continuously until they are finally too heavy for the updrafts and they fall to the ground. With even stronger updrafts, the snow pellets are not only caught, but lofted back up towards the top of the cloud. Supercooled water freezes into a solid crust around them on the way up, and when they fall, they gather a slushy, mostly frozen layer on the way down. And depending on the strength of the updrafts, this can happen again and again, forming alternating layers of denser and slushier ice around the hailstones as they go on each trip around the cloud, before they finally grow too large to be kept aloft and they fall to the ground. Cut one of these hailstones open, and they will look more like an onion on the inside with layers. Collisions between hailstones can result in them sticking together and growing as one larger mass, which then plummets towards the ground as a huge knobby lump of ice. In these ways, you can get hailstones that range from pea size all the way up to softball size, and even the monsters we've seen, like this one, the largest hailstone ever recorded, which fell from a storm that passed over Vivian, South Dakota on July 23, 2010. It measured over 20 centimeters across. The danger from hail isn't just from its size, but how fast it's falling. Small hailstones can reach a terminal velocity of around 30 kilometers an hour, which can certainly sting, but the larger ones, just 8 centimeters across, the size of a softball, can hit the ground traveling at up to 175 kilometers per hour. When a hailstone that size strikes the ground at that speed, it's enough to dent metal, shatter glass, and even break bones.